Some physicists today are interested in the Godel's idea of the structure of the cosmos, because he came up with the idea that, and a very interesting idea and a plausible one, when you think about how you see the microstructure of an atom, and how you see a proton and then you see an electron that circulates around a proton. Profound question in Dr. Ernest J. Sternglass's book is, why does the electron have exactly that curve? Why does it go around the proton in exactly that orbit? And that's a question that moved him when he was between 8 and 12 years old. Another one was that when his parents were driving in California one evening, I think he was about 10 years old, 9 or 10 years old, and he was looking at the moon, and so the car was actually going away from the moon. It was red shifting, if you were, with respect to the moon. And he noticed that no matter how long his parents drove, like they would drive for a long time, no matter how long they drove, the moon remained this object in the sky that was the same size. And so then he realized, wow, the moon is really huge. It's this thing that it's not a small thing, it's a really large thing. But he also learned about different stars in the universe and how many stars you could put into, say, our sun, of some of the other stars in the cosmos. And so these are opening reflections of his in his book, Before the Big Bang, on the origin, plural, on the origins of the universe. And what we have in the Godel cosmos, if we really do live in a cosmos, if we're not. Now, Oswald Spengler, he was very skeptical about astronomy even. He said, all we see in the skies are light indices. So he was suspicious even of the very nature of light traveling to us from great distances. So he warned us, all as we really see is light indices. So, it could be that in the cave analogy of Plato's Republic, how you see the images projected on the wall of the cave, that our own, like the whole earth is like we're in the cave. And what we see, the cosmos, is a projection of an image that isn't really the truth about it. And that is something that isn't being told as truth. Now, I don't believe in that myself. I do believe that we are told the truth about some things in astronomy, and we are told the truth about some things in physics. But I believe that there's part of the truth that we get, but we don't get as much of the truth as others know. Because we haven't put probes out in space, and we have not measured. Like we, as your average person around here, has not measured the distance to the sun, has not even begun thinking about, like, how would I measure the distance to the sun? They might not have realized that you can get a parallax angle from one object in the stars, and then you can project it onto another object, and then you can measure the angle. And you can infer, by determining the area, you can infer the distance. But they don't see that. So without direct measurement, without Stephen Hawking, taking me outside and saying, now look at that thing, and look at this projection of this shadow, and look where it's right at high noon, and and we're going to measure. And without him showing me an analytical method by which he made every measurement of every angle, and then showed me the sun is 93 million miles away, or the moon. We cannot really believe that. And it quite frankly seems to me like elites would have every reason to lie about the most distant things in the cosmos, and maybe even lying about how distant they are, and maybe even having in some way veiled themselves from us, and they're telling a kind of untruth about physics itself. And Spengler warned us. He was like, what you see in the sky is just light indices, and you do not know on that basis all of what is taught in astronomy. And I think that's true. And I think it's an encouragement, though, to people to go through the science of astronomy and learn the fundamentals, as I intend to do in the future, and then assure yourself by measurement. Measure every step that you take in believing that science, and then you can believe it. You know, for many years I thought to myself, now I'm skeptical because I would always come down State Street, and there's kind of an angle on State Street as you come down State Street. There's just a slight, maybe like a 15-degree angle, or maybe 18-degree angle as you come up to the stoplight next to a pharmacy there on State and Alpine. And I had noticed for years that if I'm at a certain angle and the sun is to my left, in my left field of vision, that after I go through that angle, it displaces, that the angle of the sun displaces to a large degree, and to what I think is a larger degree than it would change from one position in my field of vision to another, just based on the fact that I went around like a 15-degree curve or angle. And so I'm seeing it here, and then I go around and I stop, and then I'm seeing it here. You know, here and then here. And so it had caused me to question, is that really could that be 90? If that were 93 million miles away, but it was huge, as they say it is, would it actually move that great of a degree? And, you know, it's a question I'd have to ask a mathematician or an astronomer, and maybe Stephen Hawking would say, yes, it can, in your field of vision, it can shift to that degree. But I had been skeptical of it ever since. And I had begun thinking that the sun might not be 93 million miles away, but we might think that it is. And then I saw this film with Eric Dollard online, and he's like, the sun's like this hollow thing, and there's nothing going on inside of it, and there's no fusion or fission going on in it. It's like, and he's just saying, like, you know, you can't even see that thing. There's no light in the cosmos, and he was just contradicting everything. If you look online and see Eric Dollard, Dollard, you can see his questions about energy and physics and all these things. But presupposing that I'm wrong about that, and that what we're told about astronomy, when I read a great book like Sternglass's book, that he's gone through these experiments. He did work with Westinghouse. He did meet with Einstein. He did meet with Niels Bohr. He did meet with Feynman. And he did verify these things about the atom and about the cosmos. Then it seems true to me when you look at the solar system and the way the atom of each planet is kind of in a particular orbit with respect to the sun. The sun seems like it's the nucleus of the atom, or the Earth. And the other planets are something that maybe over time, you know, maybe if you go back far enough in time, that Mercury, Venus, Earth, Mars, and so on, just were actually inside the core of the sun, and over time, as the sun generated more energy, it first pushed one of those out, and then it pushed another one out, and then another one, and then another one, and so on through the 9 planets that we have. And so it looks to the eye of an astronomer like the solar system is part of an atom, And so when Sternglass says the whole cosmos is that way because it starts out as an embryonic atom, and what it is doing today is just separating parts of itself from itself, and that's what creates the galaxies that we see in the sky. That seemed to have a kind of plausibility to it, because it's like what they see at the atomic scale. And then it's like your eyes at the normal scale are seeing that at the level of the solar system. And then Sternglass says, well, put your eyes now at the level of galaxies and at the largest and most distant and most energetic objects like quasars. And he says that the whole thing really is just this one atom that's separating itself from itself in each division, and it's still going through these divisions, and it's got some more divisions to go through yet before the cosmos reaches its ultimate size. And then by implication of his argument, then at that point, and this is why I phrased it in my writing, that Newton concluded that the greatest mass was added to, because when it reached the greatest mass, Sternglass thinks it'll be stable at that point, and it will actually remain in that position forever. Whereas I think that at that point, it will add one mass more to the greatest mass, and then it will contract and go back inside of itself into one point, and then it will go through the whole process of dividing itself again, and then go through that process forever. And it's just one of the ways that physicists tell us that the cosmos could end. One of them is that it'll spread apart, and all matter in the cosmos will spread so far apart that there'll be no potentiality for life. Sternglass doesn't think that's true. That is, he thinks it's absolutely a stable atom, and that it will sustain life forever. And I kind of think that too, except that I think that it goes through that cyclical pattern, and it just divides itself from itself in every way that it can. Like it explores every possible path of creating geometric shapes of galaxies and so on, spiral galaxies, for example, or elliptical galaxies. And so that's what I think, and I think of it as actually two central trunks, like the trees in the book of Genesis. And one of them is a trunk one of them is a huge trunk. It's dividing itself now, Sternglass tells us. But that thing is the cosmos of all cosmos. Like that is every particular thing that could ever be true. And then what happens is, what comes out of that, if you will, is actually our particularity, what we're experiencing right now in this particular phase of the cosmos is what I call the tree of good and evil. See, the tree of life is the tree that is everything that could ever be, that will be sustained forever, and it is in the cosmos already because we differentiate from it as the experience we're having right now. And so that in long enough eons of time, that those two trees, they push together, if you will, and you see the spiral galaxies in Sternglass's book. I could show you the diagram right now, and the arms of it reach out, if you will, like the roots of a tree. And so these two things are twisting and cylindrically rotating, and so one goes inside of the other, and then when they come out and differentiate, and it happens so quickly, at fraction of a fraction of a fraction of a fraction of a trillionth of a second. So nobody experiences it. Like nobody feels that it's happening. But it's happening at every minute, just like you don't feel the motion of the Earth around the sun. But it's happening at every moment, and in every galaxy out there. You have this process happening with the tree of life, which is everything that could ever be, and then the tree of knowledge of good and evil, which is the experience that our free being is exploring this very minute. And that's the Godel cosmos.